In example 4, we've been given angle A is 54 degrees. So I've shown that in the bottom left corner. Angle B, or side B, which is adjacent to side angle A, is going to be 12. And side A, which is opposite to angle A, is 10. So when we take a look at this situation, we have an angle, side, side situation. This is an ambiguous case. So we have, because of the angle, side, side, we have to consider two triangles. So here I have the angle and opposite side pairing. So we have the pair here. So I'm going to set this up. So sine of 54 degrees over side length of 10, that's our pairing. And that's going to be equivalent to, well, we've been given side B. So I'm just going to put that in here. Side B is 12. And the angle that goes with side B is going to be angle B. So we have sine of B. So I'm going to end up solving for sine B. And then I can solve for angle B. So sine B, when I work this out, I'm going to rearrange this. So 12 times sine of 54 degrees over 10. And the decimal value for this works out to be 0.971 when I round that. So then angle B, I'm going to call that angle B1 because that's from my calculator. I'm going to do the inverse sine of that. And angle B1 I get is a supplementary angle, so the acute angle 76.12 degrees. So the way I've drawn this happens to be the acute angle, so that's 76.12 degrees. Now there is an alternate, so I'm going to call that B1. There's an alternate situation here where this side length of 10 could have then gone in this direction. And then this represents another angle B, which I'm going to call B2. So then angle B2 is supplementary to that angle. So that works out to be, when I subtract from 180 degrees, it's going to be, it looks like 103 degrees, 0.88. Okay, so that would be the angle that would be made in that orientation. So once I have this, I'm going to solve for one triangle at a time. I'm just going to focus on the blue triangle first. So using the 76.12 degrees, I'm going to solve for angle C, which I'm going to go C1, and that will be this big angle here. And I'm going to find that by subtracting from 180 degrees. So I have 54 plus 76.12 degrees, and then subtract that from 180, and that gives me 49.88 degrees. Okay, and then I can solve. I've got now that big angle. That angle is going to be 49.88 degrees, and that allows me then to solve for the other side here. So that the side length C, which I'm going to call C1. So writing it this way, side C1 over the angle C1 is going to be 49.88 degrees. Okay. That's going to be equal to, and I'm going to just use my original pair of sine of angle 54 degrees, and that's going to be the side length. It's going to be on top, so side length of 10 over the sine of 54 degrees. Okay, so side length is on top, the sine is on bottom. I'm going to solve for side length C. So it's going to be 10 times sine of 49.88 divided by sine of 54 degrees. And when I calculate the length of C1, it looks like the length of C1 I'm going to have to put that in my calculator here. So length of C1, when I calculate this, I get 10 times sine of 49.88, and then divided by sine of 54 degrees, and I get 9.45. Okay, so that's going to be my side length, C1. And that's going to be the length of that blue line. So this length here is 9.45. Okay, so then I finished that, and I need to then solve for this side length here, which is going to be C2. Okay, so first of all, I need to find the angle C. Did I solve for that? Yeah, I need to solve for angle C2. So angle C2, when I subtract that from 180 degrees, so 54 plus the bigger angle of 102, or 103.88, and then subtract that from 180, the top angle is 22.12 degrees. So this angle in here is going to be 22.12 degrees. Okay, so that's going to be the angle that makes that red triangle. And then I can solve for C2, so side C2, using that angle. So sine of 22.12 degrees is equal to, and again, I'll use my original pairing of side length 10 and sine of 54 degrees, and rearranging that expression, so side of C2 is going to be 10 times sine of 22.12 degrees divided by the sine of 54 degrees. Okay, so I'm just going to work that out. So 10 times sine of 22.12, and I'm going to divide that by sine of 54 degrees, and I end up with a side length of 4.65. Okay, so then this side length in here is going to be 4.65 based on that triangle. So now I've solved all the side length and angles of the blue triangle. And for the red triangle there, I have all three angles. And now I have the third side. C2 is going to be 4.65. So I've solved both triangles. Again, make sure that you've organized all that information so that it's clear that I have all three angles and all three sides.